Thank you. Hello, everyone. Complete pleasure to be here sharing this with you. Um, I'm Fran. I'm the co-founder of Giza, where we are building AI infrastructure on how to plug in these systems in a reliable way for smart contracts and blockchains. And the product that we are building is agents, AI agents, which is something that is quite trendy lately. And I'm going to walk through you on how we approach this problem of plugging agents into smart contracts, speaking to protocols, and what are like the advantages. Currently, we have a monolithic blockchain systems where we have different smart contracts. For example, in the DeFi space, we have lending protocols, we have bridges, we have AMMs, but all these dApps are completely isolated, mostly from each other. If like a new person comes into working in Web3 or into the Ethereum blockchain, they don't really know like exactly how to do things, like how to do a swap, or if I put my money into a liquidity pool, what happens, what is impermanent loss. Most people don't know about it, and how to even be protected from these kind of systems. So what we are creating is agents that abstract away all these UX problems or potential risks, like from dealing with impermanent loss or liquidations in collateralized loans and bridging through chains with these agents interpreting with multiple smart contract or DeFi protocols. But what is an agent? This is a very simplified way to put it. We have agents with three main components. One is the observer, which is basically looking into what is happening in the blockchain itself or the actual protocol that is going to be composable on top. Let's say is observing a liquidity pool in Uniswap V3 with the ETH USDC pair. Just tracks the positions of the users as well as withdrawals and deposits. Then there is the second component, which is the trust minimize ML. We will go deeper into this part later, and is how we can create ML behavior to inside the agent to solve a specific problem given the observation that we have. So in this case, one example could be a model that rebalances a liquidity pool position in Uniswap V3 to reduce impermanent loss based on volatility of the assets or the markets, etc. And the last part is the intent, which is how we interact actually with the liquidity pools in order to do this rebalancing in the liquidity pool. If we go a level deeper, how this looks like is that we have two different parts. One part that is happening off chain and one part that is happening on chain. The observation in the end, what we take as input is just very curated data that we get from the chain. So we have the transactions and the event logs. We just process that in order to create like more curated data that is in features and labels, which is something that is needed for machine learning. And then we feed it into the model. But this model is a very special model because it's not just an LLM or a traditional machine learning model. Is with a technology that is called CKML, which means that if we have a trained model, we can generate inferences and each inference that we generate creates a knowledge proof. So this way we can always trace back, okay, this model generated this inference and is linked to this data. So we have full traceability of what is happening. That is something very important for agents to understand what they are doing, especially if they are going to be handling our money. And then what we do is going to the intent part, which is let's execute the transactions or the rebalancing with interacting with the smart contracts. And in order to go to this state, what we need to comply with is the verification. And the verification is once we have the inference of the model, we need to make sure that the CK proof associated with that execution is correct in order to proceed with the execution of the smart contract. We don't want to have, for example, an AI agent that is running LLM and just randomly hallucinates, and instead of just executing your transaction for doing a swap, it just goes and sells your tokens, for example, because there is no way to deterministically understand the behavior of these models or have flexibility on how they work. But why do we use CKML in the first place? Because there's like very much overhead. CKML itself is not as easy as you train a model and that's it, and it's just generating CK proofs out of the outputs. There needs to go through a process of transpilation, which takes your source machine learning model and converts them into a CK circuit. The CK circuit, currently we support like multiple proving systems. We support the Stark-based, Snark-based. There are like different possibilities depending on what you're trying to build. If it's like privacy preservation, if you just want to have integrity, so we can choose whatever proving system we want. But the main features is attribution on what the model says it can do and what it performs. So we can have this traceability, and we can reduce the trustworthiness. We can increase the trustworthiness of these agents. So it's not something that hallucinates like LLMs. But the problem is that it comes with an overhead, because it's not just now doing the inference, but it's doing the inference of the model plus doing the proof generation and verification of that proof. What we are working on inside Giza, we're creating very specialized one transpilation methods for these models that are very reliable. And secondly, very optimized CK circuits that represents the behavior of the trained machine learning model. This way, we can have a very fast proving time, as well as having a very low execution time for the given algorithm that we want to make verifiable or traceable. So in this case, as you can see here in the slide, what we put is one of the latest implementations that we did, which is for an XGBoost model that is verifiable, where we brought the cost of generating a proof almost to zero for, in this case, it was like, I don't know if you're familiar with XGBoost models, but it's like the efficient trees. In this case, it was 2 efficient trees with 2 features as input. And if we go a little bit deeper, okay, how this actual technical architecture of how an agent works. So we have what is going to happen in the offchain side with the CKML models, where we get the observation from the chain, which is like a set of data in order to make inferences. It fits into the CKML model that is going to make a prediction. And this happens remotely in our infrastructure in order to have like reliable scalability and monitoring of how the model is performing. We generate the inference, and then in your local or your client side thing, you can have our Giza agents framework. The framework is permissionless and open source, can be executed anywhere that you want. You can have your agent running in your laptop or in the cloud or anywhere. And there is where you generate the CK proof and verify that everything is correct. Once the verification of the inference is correct, we can go into the intent execution, which is, okay, in the case of liquidity pools, we just take out some of the assets of the position and just increase the position in the other asset of the position. Each agent also has a wallet component. So instead of having remotely access to your agent, you are in control of everything that is happening there. So every agent is linked to a wallet. In this case, the wallets that we support can be a wide variety, so you control the private key of them. You support AOAs, we support the construction as well, depending on a specific chain. Specifically, we cover a construction on a StarNet, but also we support hardware wallets for doing these interactions, like a Ledger or Trezor or even multi-sigs if you guys want to run agents through a multi-sig with Safe. That's also possible. And then from there, with the intent programming, you can just define what is the logic that you want. You want to target an AMM, you want to target the landing, the liquidity pool, or whatever it is. You can just interact with almost any chain. We support Ethereum, Polygon, Arbitrum, Base, zkSync, Optimism, almost all of them. So you can create these composable agents on top of protocols. some of the use cases, just to give you some light on what we can do with these AI agents. I told you about the liquidity pool use case where the main target is to reduce impermanent loss. So users don't need to really understand what is impermanent loss or do a rebalance of their position from time to time. This is automatically done by this agent where you just deposit your token pairs and it will be automatically managed. Other use case that we're also working is with Pendle protocol, where we are managing the yield of how these token bearing assets work. What we do is based on the risk and the volatility of the market, we can increase or decrease the deposits inside what they call as vaults and increase the yield in a very safely way. The other one is safe looping, and safe looping is an agent that works in Aave or any kind of lending market where it creates leverage positions, but this leverage position is very dynamic in the sense that depending on the volatility of the market, based on a prediction of the model that is inside the agent, it can reduce or increase your leverage in order to avoid the liquidation of your loan, adding or removing collateral. There are like more use cases, and we can go for a long time here, but I don't want to take so much time because also there's another speaker there. This is a QR code where you can just get started with the framework. It's already live. You can start building agents for Onchain and using any kind of functionality that you may want. And yeah, thank you very much.
Thank you. So, other questions? Yeah.
Hi, thank you for your presentation. You said that you can reduce the proving time for your ZK-ML applications. Is this the ZK-ML part of your framework, is it open source, or is there a way to reach a publication or something where we can see how is this being performed?
Yes, everything that we do is open source. We want to just encourage the open source community to just build things on top. So everything that we create is open source. Actually, the article of this graph is also public, and the repository itself for the benchmark as well. So you can just reproduce all the results that we create. And if you want just to create a publication, just feel free to reach out to me and we can help out.
Excellent. Thanks.